This is 7th grade science. We're going to talk about Module 9, which is all about physics. Physics is what you're going to study in 11th grade. In 9th grade we do biology, 10th grade is chemistry, and 11th grade is physics. The first thing we talk about in physics is motion. Everything is in constant motion. I'm in motion. The air is in motion. Water, liquids are always in motion. The molecules are moving around, sliding against each other. And even solids are in motion. The solids of this chalkboard and this wall are actually moving. We can't see it because they're moving at the atomic level. The atoms and the molecules that make up these solids are vibrating. And so everything is in constant motion, both living and non-living things. So when we talk about physics, we talk about relative motion and who's moving in relation to whoever else. If you're sitting next to your brother in a moving car and you look over at your brother, it doesn't look like he's moving. It looks like he's sitting still. But if your other brother is standing outside and watching the car go by, it looks like you're moving very fast. And so that's what we mean when we talk about relative motion and the reference point, where you're standing and what it looks like from where you are. I'm just going to go really quickly today since this is a video. But we talked about, in the book, you read about speed versus velocity. And these are very similar quantities. What's the difference between these? Brian, you're the only one I get to call on today. What's the difference between speed and velocity? Speed tells you how fast something is going. Velocity also tells you how fast something is going, but with the direction. So we could say speed, I'm driving 60 miles per hour. And this is 60 miles in 1 hour. It tells you how much distance you've covered in how much time. And that's the units for speed. Velocity tells you the speed plus the direction. So 60 miles per hour south, if I was headed down towards Midland, that's velocity. So we didn't learn this in the book, but speed is called a scalar quantity. It's just the number. And velocity is a vector quantity. It tells you the number plus the direction. And what is acceleration? Yep, when you're either speeding up or slowing down. So it is the rate of change of speed. So if my speed increases, I am accelerating and getting faster. If my speed decreases, I am slowing down, accelerating in a negative direction or decelerating. So deceleration is a term we don't really use in physics, but it does help you understand what negative acceleration is. Okay, when you get to physics, especially when you get to calculus, this will make a lot more sense. You get to do all the math and the graphs of these things, but we don't have time to go into that in 7th grade. So let's move on to Newton's 3 laws. You will have to memorize these because these will be on your quiz. The first law we can sum up with one word: inertia. An object at rest wants to stay at rest, or an object in motion wants to stay in motion unless acted upon by an outside force. So if you are sitting still, well, not you, let's take an inanimate object. If a ball is sitting still, it's at rest, it's going to stay at rest unless something acts upon it, such as somebody kicking it, or the wind blowing and moving it, or it being on a hill and gravity acting upon it. And an object in motion wants to stay in motion. Once that ball is moving, it's going to keep moving unless it is stopped by something. Newton's law number 2 can be summed up with the equation F equals ma. Force equals the mass times the acceleration. Now in science, I never use an X for times because it looks like a variable. In upper level math and in science, I never use an X because it looks like if you guys are doing variables in math already. Are you doing variables? It looks like an X. So I always use this little dot to, or parentheses to denote multiplication. So force is equal to mass times acceleration. That's law number 2. And law number 3, for every action, there's an opposite and equal reaction. Okay, so if you're both standing on ice skates, you and your friend, and you push each other, if I pushed Brian on skates, I would also go backwards. That would be the opposite and equal reaction. We don't get to observe law number 3 very often on Earth because we have so much friction in our lives that is a force that stops us. And we're going to do the experiment with friction in just a minute. So there are 4 more forces we're going to talk about, and then we'll get to the experiment. The first one is the strong force. So if you guys remember, we looked at the structure of the atom. When we get to chemistry in 10th grade, we're going to do this a lot. We have protons in the nucleus. I'm going to draw 3 protons. And it is the number of protons in the nucleus that determine what atom it is we're dealing with. So the number of protons give us the identity of the atom. Does anybody know what atom has 3 protons? My kids.
Titanium.
Nope. Good guess. 3 protons. Anybody know?
Hydrogen.
It's a good guess. Hydrogen has 1. No. Julia, how many protons? What atom has 3 protons?
Jelly.
Nobody knows. It's lithium. Lithium has 3 protons. Lithium, I believe, has 3 neutrons. The number of neutrons actually doesn't really matter. They're neutral, so they don't give the atom any chemical properties. What the neutrons do is affect the weight of the atom. So each one of these particles weighs 1 atomic mass unit. But for chemistry purposes, the weight doesn't determine its chemical properties for the most part. So we've got 3 positive protons in here, 3 neutral neutrons, and then orbiting around the nucleus we have 1, 2, 3 what? What are these things orbiting around?
Electrons.
Yes, electrons, and I abbreviate them with E minus. They have a negative charge. These protons are P plus. Okay, so we have our protons in the middle. They're positively charged. Our electrons orbiting around, they're negatively charged. What keeps these protons together in the nucleus? They're all positive charges, so they don't want to be next to each other. Positive charges repel each other. So what keeps them together? What is stronger than the force of repulsion between those? What was that called? Brian? It was called it's right here.
The force that is strong.
The strong force, yes, overcomes the electromagnetic force that repels. So the strong force is what keeps our nuclei of all of our atoms together. Yeah, Donald can read that now. So that's the strong force. The next force is gravity, or the gravitational force. And gravity is an attractive force between any 2 objects that have mass. And for you kids who like math, this is the equation for the force of gravity. Force of gravity is equal to the gravitational constant. And a constant is a number that never changes, that has been determined through experiments. So we have a gravitational constant times mass 1 times mass 2 all over the radius, which is the distance between those 2 masses, squared. So as the mass increases, the force of gravity will increase. Either mass. So let's say that this is me, mass 1, and mass 2 is the Earth. I have a mass, and the Earth has a mass. That Earth's mass is very large, meaning that the force of gravity is going to be large. What about my distance to the Earth? I'm standing right on the Earth, so my distance is actually very small between me and the Earth. And so this number being small means that the force of gravity will be larger. If my distance increases, like if I go up into outer space, my distance or my radius will increase and the force of gravity will become less, and I'll become more weightless as I go up into outer space. We can calculate the force of gravity between any two objects with mass. So between me and one of my kids over here, there's some gravity attracting us together. Since our masses are so small, we don't feel that. Between the Earth and the Sun, there's a large amount of gravity, because even though the distance is far, the masses are very large. And so there's gravity that holds our Earth in orbit around the Sun. Okay, so if you like math, then you'd like to see that force of gravity is proportional to mass, and the force of gravity is inversely proportional to the radius squared. We'll do lots more of this when we get to chemistry, and especially physics. So the third force is the electromagnetic force. Electromagnetic can be abbreviated EMF. This can be attractive or repulsive. And we know this just by everyday life. If you have two magnets, they're either attracted to each other or repelled by each other. Yes, magnets.
Let's go together.
So if you have trains, toy trains that have magnets that connect, some of them connect, but if you turn that train around, those magnets will repulse each other. Yeah.
From the Thomas the Tank Engine.
Yep.
Donald.
We have Thomas the Tank Engine trains that do that. It's the north pole and the south pole of the magnet that get attracted to each other. If you have a south pole and a south pole, they're repulsed by each other. All right. And we talked about the Earth. This was one of your on your own questions. The Earth having a metal core that moves, has convection in the core, and that causes a magnetic field. It induces a magnetic field that goes around the Earth, and that protects us from the sun's radiation. So we're going to do experiment 9.1. I have to move over here because my kids are doing school all over the place.
I'm the cameraman.
That has to go this way. Brian's going to perform the experiment for us.
Brian.
So this is experiment 9.1. Take out your books and follow along. Take out your books and turn to what page?
Page 2 million.
Experiment 9.1.
Get out of here.
We have our materials. We have a large book, a paperclip, a small pencil eraser, and 2 lumps of clay, about the same size as the eraser, and our ruler. What happens when various objects are placed on an inclined surface? So what we're going to be looking at in this experiment is the friction between these objects and the book. And friction is a force.
9.1.
9.1. What page is it?
4 or 7.
Page 473. There you go. So at the top, write your name and the date. Today is January 27. Procedure, and we are not making any changes other than you're watching on a video instead of doing this in class. Okay, step 1, lay the book flat on the table. Roll 1 lump of clay into a smooth ball. Line up, Brian, you have to do this. Line up the paper clip, the eraser, and the ball of clay along one short side of the book. So line them up here. Okay, very slowly raise this side of the book so that it forms an inclined surface or a ramp. And as soon as something starts rolling, you're going to stop lifting the book. So once the first item begins to slide, stop raising the book and we'll measure how high our book went. Okay. So measuring, should we use inches or centimeters? That is, you want to do centimeters? 9 centimeters even. Okay, so turn your page in your lab book. And this is on the next page, 474. Record the height of the incline and which item slid first. So this is the first part of the data table. Can you see it? On page 474, right here, we're going to write 9 centimeters.
I'm gonna put it back.
And what slid first? Right, 9 centimeters.
Is that CM?
Uh-huh. 9 cm. And what slid first? This little guy. The eraser. Okay? Now, we're going to do it again. Raise it up to 9, and then we'll see what the second one is. So go ahead and raise it up to 9, and the eraser should slide down again. Okay, and keep going until the second item slides. All right, what are we at? 14 centimeters, and it was the paper clip. So this is on the next page, step 6. Record the height. That was 14 centimeters. And it was the paper clip. How do you spell paper clip? Brian won't let you cheat on his book. All right, come back here,
He
Phil.
just doesn't want you to know all the wrong answers. What?
I said, put the camera back on here. Now we're going to raise it until the last item slides down. So we should lose our eraser around 9 centimeters, paper clip at 14, and put the clay ball.
Why do we need 2 of them?
You'll see. Keep going. The ball that never falls. Okay, Brian got it to roll at 21 centimeters.
Sticky.
Why did it stick? Yes, it is sticky clay. Phil. All right, write down 21 centimeters for the ball of clay.
Look at my book.
Okay, now we're going to take the second lump of clay and flatten it into a small disc shape. Our clay is really sticky. And we're going to do this again. This is step 9. Can I see your book? Okay, raise the book again. Yep, we don't want them to be sticking.
Ew.
Which one do you think is going to slide first? There we go. All right, keep going. That was at 15. And failure to launch. Okay, write down which piece of clay fell first and how high you have to tilt the book to get it to fall. There it goes. That was a 180-degree tilt. No, sorry, 90-degree tilt. So write it down in your book. The ball of clay fell first at, I think it was 15 centimeters. And the disc of clay didn't fall until we had gone 90 degrees. So we had very unrepeatable results in this experiment where each time we raised it, the objects fell at different times or different heights. And that highlights the fact that to get reliable experimental results, you need to repeat your experiments over and over again and average all of your data. But we don't have time to do that today, so we're going to go with these results and talk about what happened.
What about for conclusion?
So for your conclusion, you're going to write that we saw objects fall down the book at different points. different heights of the book because they all had different amounts of friction. What do you think had the most friction? Try this again. What had the most friction? Looks like our eraser has the least amount of friction. The paper clip was next. The clay ball is next. And finally, the clay disc. So our eraser had the least amount of friction, followed by our paper clip, then the clay ball, and finally our clay disc. That disc is still holding on. Okay, so write that in your conclusion, what happened. Friction is actually some attractive forces between the two surfaces, but we can talk about that more next week. So write up your experiment, and I will see you in class next week.